Okay, guys, so here I have four problems that we covered in Unit 1. I'm going to be going over each one of them separately. Okay, the first one is the translation, the second one it's the reflection, the third one is the rotation, and the last one is the reflection again. There were two variations of questions involving um, reflections. So the first one, the easy one, the translation. Okay, let's do that first. You will notice that compared to Unit 3, in Unit 1, we had units of measurements. We knew how many units we had to go left or right or up or down. We had a grid. We had an x-axis and a y-axis. Okay. Um, in Unit 3, you notice that we don't have any of that. Although I believe Unit 1 was a little more challenging because of this. Okay, so let's focus on this problem over here. All right, so I want to translate by applying this rule. Okay, so remember that x is the horizontal axis left and right, and in this case, I want to go minus 5 units on the x-axis. So I'm going to go 5 units left. And then the y-axis, well, that's the vertical axis up and down. So because of this rule, I want to go up 3 units. So what does that mean? Well, every point is going to do that. Every point is going to go 5 units left and then 3 units up. So let's do that. Let me show you guys. These are the units. You may not be able to see the little squares as well as I can. So let me mark some of them so you see. Okay, that's the vertical axis, the horizontal axis. And then this is the y-axis. And these are my units. I'm using grid paper to make it much easier. I don't want to be guessing on a plain paper. So let's begin. Okay, I want to go 1, 2, 3, 4, 5 units left. All right, and then from here, after going 3 units left, I want to go now. After going 5 units left, now I'm going to go 3 units up. 1, 2, 3. So right here, this is my new point. After going 5 left and 3 up, this is my new point, my new A, which we're going to call it A prime. You need to make sure you put that little comma on top of your new letter. Okay, so this is now A prime. Same thing with B. I'm going to go 5 left, 1, 2, 3, 4, 5, and then 3 up. 1, 2, 3. So this is where my new B is located. That's my new B prime. Now if I want to, I can go ahead and trace my new line A prime B prime. So you notice we technically just took this line, we dragged it 3 units, 5 units left, and then 3 units up. And this is the new location of our line AB. And that's it. Some questions you may see that they're going to ask you for the new coordinate. Well, the original coordinate of A is 2 units to the right, that's positive 2, and then 1, 2, 3, 4, 5 units down, negative 5. This is the original coordinate of A. The new coordinate of A, it's now 3 units left, so it's minus 3, comma, and 2 units down, minus 2. So this is the new coordinate of A. All right, same thing would be with B. The problems may ask you to write the coordinates. They may not necessarily ask you to do to graph it. All right, that's the translation. All right, let's move on to the reflection. So in this reflection, remember for a reflection, you need a line of reflection. In this case, you notice there's no line given here, but it's giving me the equation of the line. And sorry, I wrote the instructions for this problem wrong. I should have written reflect across the line, and then this is the equation of the line. I'm going to show you guys a new trick here. Um, I kind of wanted to use this trick in class, but we didn't get the tool, but I got a way around it. Well, first let's graph the line of reflection. Okay, remember the number at the very end, that's my y-intercept, and it's 3, positive 3. So right here, that's my y-intercept, 3 units up. Okay, 1, 2, 3 units up, that's my y-intercept. My slope is the one that has the x, so my slope goes 2 units to the right and 1 unit down because it's negative. I can trace my slope a few times just to make sure. 2 units right, 1 down, 2 units right, 1 down. So my slope is this. I can also go backwards. I can go 2 units left, 1 up, 2 units left, 1 up. So yeah, this is the slope of my line of reflection. Now I can actually trace the line. The purpose of making several points is so that I will create a more perfect line of reflection. Yeah, because sometimes connecting 2 points may not be as accurate as connecting several ones together. Now this is a perfect line of reflection. I want to reflect across this line. Here's the trick. Okay, here's the trick. You can take any object that has right edges. Okay, because these right edges represent a straight line. Represent a straight angle, a right angle. Sorry, straight angle, it's 180. Represents a right angle, 90 degrees. And I don't know if you remember this, but the the reflection of this point across this line, if you were to trace a line connecting B and your new B prime after the reflection, the line connecting B and B prime will create a perpendicular line to this line of reflection. So I can actually use this straight chord, this right chord, align it with the line of reflection so that it's perfectly aligned. Okay, and right where B is, make sure it's perfectly aligned. Right where B is, you can trace your line connecting B and the line of reflection. This line is made at a perfect right angle. You can now bring your ruler and keep tracing the rest of this line all the way across. Remember that the distance from the line of reflection to B is going to be the same as the distance from the line of reflection over on the other side. You can measure with a ruler what's the distance. In this case, I get 1.4. You may not see it, but it's just use the ruler to measure the distance from here, the line of reflection, to your point B. I get 1.4. So I'm going to measure 1.4 over on the other side. So from here, 1.4 is right over here. So this is my new B prime. So this is a more faster method to reflecting a line. Previously, the way that I showed you was to find the opposite reciprocal of the slope of this line, and then from this point, trace the opposite reciprocal uh, slope from point B. So you will trace this perpendicular line. I'm going to show you this shortcut. It's good, it's better. Still, you should know both ways. It's not just about knowing the tricks of how these things work. But yes, there we go, perfectly aligned. Now I'm going to trace my line that connects. There you go, a nice perpendicular line. I can use my ruler to keep tracing this line across. And there you go. Now I'm going to measure the distance from point A to my line of reflection, which is exactly 1.7 units. So 1.7 units over on the other side. 1.7, it's right there. So this is my new point, A prime. And that's it. The reflection is going to be here. And there you go, a perfect reflection. All right, so yes, maybe try to get some sort of card, okay, that has a right angle. That'll be the best thing to do. Yeah, there's also rulers that have the straight edge. Those are called I don't know what they're triangle rulers. Yes. All right, let's go to the next problem, the rotation. Okay, for the rotation, I'm sorry, there's no shortcut. You have to use this, the protractor. Well, there is a shortcut, but the shortcut only works for rotations that are 90 degrees, 180 degrees, 270 degrees. But when you're asked to do a rotation 70 degrees, there's no way around it. You need this. So I want to rotate 70 degrees clockwise around point C. Hopefully you guys remember these type of problems, that you need a center of rotation to do a rotation. Okay, you need a center of rotation, which in this case is given to be point C. You also need to know the direction you're rotating. In this case, I'm rotating clockwise, so I'm rotating this way. So let's do this problem. Hopefully you guys also remember this process. Okay, so first thing, choose a point to rotate. Let's rotate point P. So the very first thing that I want to do is trace a segment connecting the center of rotation and the point that I want to rotate. So there you go. That's my segment. I want to rotate point P. So again, a point from the center of rotation to the point that I want to rotate. This is going to help me line up my protractor to to the to the line and the point. You want to make sure that your protractor is perfectly aligned. Okay, so it is perfectly aligned. I'm using this little line that the protractor has here. I'm aligning it perfectly there. Perfect alignment. 70 degrees clockwise. So you see the 70 degrees, it's here. You can also mark it right here at the 110, because the 110, it's the 70. So 70 degrees. There's my mark. Make a little mark, make a tiny mark. Sorry, you can barely see it, but there's my tiny mark. Okay. Now I want to create another segment, again, from the center to that little tiny mark that I made. There you go. This angle right here, it's 70 degrees. All right. The next step is to measure the distance from the center of rotation to my point P, which turns out to be perfectly 2 centimeters. So over here is going to be 2 centimeters over. So right here, this is my new P, which I'm going to call P prime. There you go, point P. I'm noticing that in this problem, I may get my triangles overlapping. That's fine. Let's see what happens. So point C, this time I am going to rotate point Q. Okay, now I'm going to rotate this point. Okay, again, let's line up my protractor with point C pointing at point Q, 70 degrees. 70 degrees. There you go, perfect alignment. And yes, you may notice 70 degrees. You can barely see it, but 70 degrees is right on top of this line. 70 degrees is right on top of the first line that I did. It turns out this angle is also 70 degrees, but that's fine. Um, I don't have to trace a second line because I will pretty much be drawing a line on top of this one. The distance from C to Q is about 1.8. So you want to go 1.8 units this way, 1.8. Wow, turns out to be right on top of P. So point Q and point Q prime and point P are right on the same place. Um, Finally, point point R, and trace my line. Now I'm rotating point R. Let me align my protractor to point R. Perfectly aligned, and let's go 70 degrees. There's my 70 degrees right there. And you can barely see it. 70 is right there, so there's 70 degrees. Now let me trace my line, connecting again my center of rotation to the 70 degrees. And there you go. Now I want to measure the distance from the center of rotation to point R. Sorry, the ruler is too long. It's 4 centimeters. So I want to go 4 centimeters on that new line that I just did. 4 centimeters will be right there. So this is my line, my point R prime. And there you go. I got my point P prime, I got my point Q prime, and I got my point R prime. I'm ready to trace again my triangle. So from P to Q, then from Q to R, and finally from R to P. You should notice that when you do a rotation, the shape is not supposed to change the way it looks. You're supposed to get the exact same shape. It was just rotated this way. In this case, it was rotated 70 degrees. If you're still having trouble understanding rotations, there's a video that I made just focused on rotations. Okay, you can look that one up. Now, this problem may have been one of the most problematic during the test. In this problem, you're trying to find the line of reflection, the equation of the line of reflection. Again, you may need your card or something that has a right angle. Okay, and first thing you want to do is connect point A and A prime. So yeah, make a line connecting them. Again, notice this is technically what we're looking for. We have a line connecting B and B prime in this case, and we just want to find the equation of the line that would be perpendicular to this line. So uh, notice you also want to find the midpoint, okay? Because that point in the middle, that's where your line of reflection is going to go through. So a good thing to do before you start using your card is to find the midpoint of between A and A prime. So let me measure the distance. The distance I get is 5.6. Half of 5.6, you can use your calculator. If you don't know what's half of 5.6, okay, so you can just do 5.6 divided by 2. That gives me 2.8. So I want to measure 2.8 from either A prime or A. 2.8, that's going to be half the distance. 2.8 So right there, that point is the distance between point A and point A prime. Okay, so I'm going to use my card to trace a perfect perpendicular line. There you go. Okay, you can use your ruler to keep drawing the rest of it. And there you have it. You don't have to make them this long, I'm sorry. But yeah, this line is my line of reflection. Okay, this point A is reflected across this line over here. Okay, that's how reflections work. And guys, it's asking you to write the equation of the line. So you want to find the equation of this line. That's an easy thing to do. Find the y-intercept. Look, my y-intercept is 3 units down. So it's y equals, the y-intercept is -3 because I go 3 units down. From here, you can trace the slope. Um, choose choose 2 points on the line. Okay, choose 2 perfectly good points on the line. This is a good point. And look, this is another good point. To get from this point to this point, I go 2 to the right and 1 down. So 2 to the right, that's the run. 2. 1 down, that's the rise, that's 1. Because I go down, that's negative. So negative. Don't forget to add your x. And this is it. That's the equation of this line. All right. So I will leave this video up to here. Okay. This is pretty much everything that you need to know about reflections, rotations, translations. Um, these were some of the most common problems that we saw in Unit 1. Another type of problem, in case I don't well, another type of problem, let me just do it, is the rotational symmetry. Let me just show you guys a pretty quick example about rotational symmetry. Let me trace a perfect square. Um, okay, so given this perfect square that I'm drawing, rotational symmetry, you can find the rotational symmetry of a shape based on, based on how many lines of symmetry you can draw on the shape. So I can actually draw 4 lines of symmetry across this shape. 1, 2, and you know where the other 2 are. 3, and 4 lines of symmetry. So based on how many lines of symmetry I have 1, 2, 3, 4 lines of symmetry. Based on how many lines of symmetry you have, the rotational symmetry of this shape, rotational symmetry, is based on lines of reflection, which are 4, and 360. So 4 divided by 360, which in this case, after dividing, this will give me 90. So the rotational symmetry of this shape is every 90 degrees. So 90 degrees will be one of my rotational symmetry. Add another 90, I get 180 degrees. That's another rotational symmetry. Add another 90, that gives me 270 degrees. And add another 90, you're supposed to go back to 360 degrees. So these are my angles of rotation for this particular shape. And guys, that was everything that we learned in Unit 1, I think. All right.